Hello everyone. Today we're going to talk about Physics 253, Week 7, problem number 27.55. In this problem, we are asked to calculate the diameter of wire that will cause a fuse to blow given the current and the current density. So this is actually a pretty helpful problem, real world. In some of the scenarios that you might encounter fuses blowing like this would be in your fuse box in your car. For example, if you uh, for whatever reason, if your one of the wires in your car um, received an excess amount of current, the fuse box or one of the fuses in your fuse box would melt because it would it wasn't made to withstand that amount of current, but also because it's keeping a lot of the other electronics in your car safe by making sure that they're not receiving too much current as well. So um, to start off this problem, we're going to be drawing on material from chapter 27.3 in our textbook. Um, in this chapter, we're talking about current and resistance, more specifically current and current density. But what we can do is essentially we need to our fuse that we have needs to blow or melt due to the excess amount of current. So I've kind of drawn a little picture of a lot of different little current vectors here, and they're causing this wire to melt here, hence the flames. Um, so this equation right here, this is actually given in our 27.3 textbook chapter, and I believe it's equation 27.13, in which we have our current density J here. And J is more typically given in amperes per meter squared. So one of the things that we're going to need to do at some point in the problem is convert this amperes to meter squared, uh, convert this to amperes per meter squared. So just starting off the problem here, what we can do is we can rearrange for A, which is going to be our area, cross-sectional area um, of the wire, and we can do that by just putting our current over our current density. In our case, we're going to have our current of 0.7 amperes divided by our current density here that I've converted um, to SI units, and then we're left with the amperes cancel here, and we're left with meters squared. From here, we can use the definition for area of a circle to get that cross-sectional area here, um, and we can just rearrange to solve for the radius r, and after that, we're able to plug in our radius to the equation for diameter, which is just 2 times the radius. And we're left with this value here in meters, but for the sake of simplicity, we can go ahead and convert this to millimeters. And in our case, the diameter of wire that would cause the fuse to blow given our conditions would be 0.43 millimeters. So thank you guys very much for watching, and I hope you have a good rest of your week.